All right, today we are going over Leetcode number 392 is subsequence. This was the June Leetcoding challenge problem for yesterday, Tuesday, June 9th, and it is an easy problem, and you'll see why when we dive into the problem. Also, it's a very not common easy problem. Here you can see the bar, it's like literally on the very, very left. So not something you'll probably see in interviews because it's too easy, but still a good exercise for you to think about how to approach the problem. You'll see why. Okay, so I'm going to read the problem, go over how I implemented the problem, and kind of the thought process behind it, and that'll be it. All right, so given a string S and a string T, check if S is a subsequence of T. A subsequence of a string is a new string which is formed from the original string by deleting some, it can be none, of the characters without disturbing the relative positions of the remaining characters. So what does this mean? An example here, they have ACE, right? ACE in that order is a subsequence of A, B, C, D, E, right? That makes sense because A comes first, then C, then E, and the order is there. While AEC is not. So AEC is not a subsequence of ABCDE because you don't find, basically the order of these letters is not contained somehow in this longer string. All right, so just remember, as we're dealing with this problem, S refers to the shorter string that we're trying to find in the bigger string. So just think S is the shorter one, and T is a string kind of like with all the other letters mixed in that we want to check to see if the smaller string S is in it. Okay, so let's go over the two examples here. All right, S in this case is ABC, T is AHBGDC, and the answer is true because you can find A, then B, then C in that order in T in some way. So remember, the order matters. It doesn't matter if there are letters in between ABC, as long as ABC exists in that order in some way in T, the answer is true. Example 2, the answer is false because there's no X in T. So that's a very clear false answer. And here are our constraints for the problem. All right, so S is upper bound is 100, T 10 to the 4th. Okay, and both strings only have lowercase letters. And let's see, take a look, which companies, question is, yeah, so only Google or whatever was logged, only 2 people logged that Google asked this. It's probably part of their like first questionnaire thing to kind of screen people out who don't know how to code. So that makes sense that they kind of give like a very like straightforward, easy problem to make sure you know the basics of coding. And the related topics, binary search, dynamic programming, and greedy. And according to the solution, actually, they're saying that these related topics, like viewing this kind of throws people off to kind of overthink it. So rather than overthinking it by being intimidated by, let's say, oh my gosh, dynamic programming and stuff, there's a pretty straightforward way of doing it, I'd say. Okay, so let's dive right in. All right, so let's go into what our thought process is in this problem. So let's think about the premise of the problem, right? You know you want to find your letters in S in that order in T, right? And it doesn't matter what comes in between T or not. Just as long as those letters exist in T and are in the right order, then your answer will be true. So what's like a very useful way for us to do that in a very direct way? It's very straightforward. It's not like kind of doing like unnecessary, extravagant work. So having a pointer for each string is something that can be very, very useful. So how would this kind of work, right? So let's say, okay, so at the beginning, of course, you're going to start at the beginning of each string. You have your 2 pointers. This one's going to be S, and this one's going to be T. And as you go through, you basically want to check if there's any match in T that is the letter you are at S, right? So let's say S is ABC, right? Right now we're on letter A. We're going to go through T to see if there's any letter A. If you see a letter A, you're like, okay, cool. Now I have to check for a letter B. So you're going to increment your pointer from A to B because you already found A in T. And then you're going to keep going through T until you find a B. And if you do, you're like, okay, and you keep incrementing S each time you find a match until you're finished with S. If you can reach the end of S, that means your answer is true, right? Because you only incremented your pointer once you found a match in T. if you don't increment your pointer in S, that means you didn't find a match in T. And so what would happen is you would reach the end of string T as you increment the pointer at T to try to find a match until you get to the very end of T. And if you get to the very end of T and the pointer is not at the pointer at S is not at the end of S, you know that you couldn't find all the letters in T in the correct order. So that's kind of the thought process and how you would approach this problem. Okay, so let's dive into the code portion of it. Okay, so I'll mention these edge cases first. Basically, if nothing, blah, blah, blah. So basically, if S is an empty string, you'll return true. And if there is nothing in T, then you will return false, because there's no way you can have S that has some letters somehow exist in a nothing. But in the other way around, which was the first case, technically an empty string is like a subset of T. Anyway, not the main code part. Let's move on to the code part. So basically, we initialize an index to start at 0, and right, that makes sense. It doesn't make sense to initialize the 0 and try to do work if any of the inputs is empty. Anyway, okay, so the current S index, we're going to initialize it at 0, and I have a for loop here that goes through each letter in T. So if the letter in T is equal to the current letter in S that we're pointing to, aka what the index is, then we will increment our index. But we need to check for something first, right? If what we're at right now, if the index is equal to, is at the end of S, you only enter this case if there's a match, right? So if there's a match at your current index and that current index is the last letter in S, then you return true because you found all the letters you needed in S, right? Otherwise, you're not going to enter this and return something. You're not going to break out of the loop. So you're just going to keep going and you just increment your index at S. The only way you exit out of this loop and return false is if you reach the end of T and you never return true because you were never able to reach the end of S and have the whole string in S be a subsequence of T. So that's why you would exit this loop. Only if you reach the end of T without everything in S being accounted for, which is why you can return false outside of the loop. And that is my very concise, short explanation. The solution has some very interesting ways of approaching it, so I'm not going to be going over that, but if you guys are interested in looking at the solution, just let me know. But that's it for today. Thanks, guys.